Today's lesson, we are focusing on the immune response. So having a little bit of a look at the primary immune response and how this builds into the secondary immune response. Just a little bit of background before we get there. Little bit of terminology to make sure that we're all talking the same language. Okay, so we have Joe the bacteria. This is not drawn to scale. Okay, so Joe, our bacteria, is called a pathogen, a disease-causing organism. On Joe's cell membrane is an antigen. Okay, so an antigen is a cell marker. It identifies. We can have self-antigens and non-self antigens. So all the cells in your body will have a particular antigen that marks them as self for your body. So any antigen that comes in that is non-self is foreign and it's going to stimulate an immune response. So Joe the bacteria with his antigen would be identified as foreign. One of the ways that's nice to remember is an antigen belongs with a pathogen, because the other part of this story is your antibody. So that is our antibody. And the antibodies are made by your body. So now you've got no excuse for mixing up antigens and antibodies. Antigens are on pathogens. Antibodies are made by your body. So that helps you get them in line. Remember, of course, you have antigens on your cells, but just in terms of the basic understanding, now you've got a way of linking them. To understand that an antigen is a cell marker, whereas an antibody is a molecule that's going to be used in the immune response. So we're jumping here to the third line of defense, the specific immune response to a specific pathogen. Okay, with protection by the immune system, we're working with active immunity in this case, because we are stimulating that response from the immune system. Things are happening, there is an active response. So what happens? First thing that happens is that Joe the bacteria is going into the body. So past all those first lines of defense, past mucus, past skin, now we're actually inside the body. And the pathogen then stimulates two lines of things. The one thing that's stimulated is your B lymphocytes. So we have clonal selection of your B lymphocyte. Remember, we're working here now with your B lymphocytes and your T lymphocytes. Those are the guys that are majorly involved in here. Okay, macrophages are also going to play a part. Neutrophils are doing something different. They come in at the very end. So to start off with, we have B lymphocyte, clonal selection. And we have antigen presentation by the macrophages. So the B lymphocyte clonal selection, here you've got what's going on is on the, let's say we've got a B lymphocyte. Okay, they've got the nice big nucleus and lots of rough endoplasmic reticulum, because these are the guys who make the antibodies. So we're making glycoproteins. We need that rough endoplasmic reticulum to get all this involved. Okay, so on the cell membrane of this B lymphocyte, you have an antibody receptor, which is complementary to the antigen on the membrane of the pathogen. Okay, so we are complementary to antigen on the pathogen. So that is how we select those B lymphocytes that are traveling around, that are complementary to this antigen. Okay, they are going to be stimulated for clonal selection. Okay, when they are stimulated for clonal selection, now we get, we'll call them for short, B cell clonal expansion. So we're talking here about the importance of mitosis, because remember, mitosis, we're doing a genetically identical copy of the cell. So the new cells produced, the daughter cells, are going to be exactly the same as this original cell that responded to the pathogen. So now we are creating an entire clone of B cells, which are all going to respond specifically to this pathogen. Macrophages presenting the antigen, this now triggers into T cell clonal selection. Okay, but let's just have a bit of a look how that happens. Okay, so our antigen, he can also be in blue. Our macrophage can also be in blue. Okay, so there's a macrophage, big cell, also with a relatively large nucleus, but not proportionately as large as the lymphocyte. Now what happens with him is antigen presentation means that he actually engulfs the pathogen. Remember that macrophages are a type of phagocyte. So they do phagocytosis. We engulf the entire pathogen, and then we take a piece of that pathogen and they put it in the cell membrane. So there's now the antigen from the pathogen in the cell membrane of the macrophage. So that's what we call antigen presentation. And that then selects the correct T lymphocyte. So now we have T lymphocyte clonal selection. So the T cells have receptors which are complementary to this antigen that's being presented. And if it's the complementary one, that one is going to be selected. And then that one, we would have T cell clonal expansion. So our B cells respond directly to the antigen on the pathogen. When we're complementary, then we get expansion, clonal expansion. Now we've got lots of B cells that want to fight that pathogen. For the T lymphocytes, we have the macrophage on the way. The macrophage must present that antigen from the pathogen. Then we have the stimulation of the T lymphocytes, clonal selection of the one that's complementary, and then expansion of that particular clone. So that now we've got lots of B cells and lots of T cells that are ready to fight this particular pathogen with its particular antigen. Because remember, antigens are specific. So different pathogens will have different antigens. So now we're going to go and we're going to talk a little bit more about these B cells. So we have our B cell clonal expansion. What's really cool is that there's a role of the T cells, okay, there's a specific type of T cell called a T helper cell, which actually increases the speed of this clonal expansion. So our B cells can respond faster when our T cells get involved. We'll look at that under those T cells. So our B cell clonal expansion, okay, we're creating a whole lot of B cells, which are complementary to our pathogen, and we actually split these into two different types of cells. We get memory cells, and we get plasma cells. Now, keep the memory cells in your memory, because these guys are all about your secondary immune response. Okay, plasma cells. This is where your antibody production happens. It is all about production of antibodies. Large amounts of rough ER producing large amounts of protein, modification to produce the glycoproteins, which are our antibodies. So plasma cells are all about antibody production. So they produce these antibodies, and they release them. And now remember, we said that the antibody is complementary to the antigen on the pathogen. So the antibodies can actually bind to the antigens on the pathogen. And what happens next is we get two other options, okay? Both resulting in not nice things for the pathogen. One thing is that, remember we said the neutrophils come in at the end? So the neutrophils are our scavengers. They are hyenas of our immune system, okay? So they're coming along and they're cleaning up and they're getting rid of things. And it's these antibodies that are bound to the antigens which then stimulate our neutrophils. So our neutrophils recognize antibodies. And then we get our phagocytosis of the pathogen. Alternatively, the antibodies themselves can actually cause all the problem for the pathogen. They can actually neutralize or they can even kill the pathogen. So it's all going to depend on which particular pathogen it is, which particular antibody it is, which particular relationship you're looking at. So we're looking at quite a sort of broad overview here. We're not looking at how specifically a pathogen and an antigen are going to stimulate these specific antibodies. Okay, so it all is going to depend on the specific situation, but these are the general things that can happen. Either the antibodies are going to result in immediate death and destruction of this pathogen, or the antibodies are going to stimulate the neutrophils, and we have phagocytosis for both, all depending on the specific situation. Okay, so that's our B cells. Okay, they've responded, they were complementary, they've expanded, they've got now produced our memory cells, which we're keeping in our memory, and our plasma cells, which are all about antibodies to get rid of that pathogen. So now let's head back and look at the T cells in the same way. So T cell, clonal expansion. So here we've had the antigen presentation by the macrophage. The T cells have been selected because they're now complementary and they've expanded. And we've got now a whole lot of cells which are all identical. And funnily enough, we have two types of cells again. So when it comes to T cells, we get T helper cells. And we get T killer cells, the assassins. So again, we have this creation of memory cells, and it's our helper cells that can become memory cells. And again, these guys are all involved in the secondary immune response. But what is the actual role of that T helper cell? Well, if you help something, then you help it happen. So these guys release cytokines, sort of hormones for cells, okay? They do two things. One thing is that they increase the B cell division rate. So it's increase the rate of the B cell clonal expansion. More cells means more antibody production. More antibody production means faster elimination of this pathogen. So the T helper cells are really helping that process. The other thing they do, okay, they actually help the T cells as well. And they do that by affecting the macrophage. So we increase rate of phagocytosis by macrophages. So more phagocytosis, more antigen presentation, more selection of the correct T cells, more T cell expansion. So everything is sort of being amped up by these T helper cells. It's really increasing the rate of the reaction that we're getting here so we can have a faster response, because we don't want this pathogen hanging around any longer than it's absolutely necessary to get rid of it completely. We don't want to extend that duration. Think about when you learn about smoking and the production of that mucus and the bacteria hanging around and all the knock-on effects that's horrible of that. So we don't want that situation. We want our immune system to be working as fast and as efficiently as possible. And the T helper cells really play a massive role in that. So the last level of our sort of team that's going on here is our assassins, the T killer cells. Now these guys are a little bit different, okay? Because remember, our B cells was all about killing off pathogens, okay? All about identifying pathogens or killing pathogens. T killer cells or self cells. Okay, so the thing is, they don't just kill randomly self cells, they destroy infected self cells, because a self cell can also present a foreign antigen. Okay, so if it's been infected, if that pathogen is hiding inside it, then the T killer cells will pick up on that and they will then destroy that one. So again, we have destruction of the pathogen. It's just that now the destruction of the pathogen is pathogen that's inside a self cell. It thought it could hide, but it couldn't escape. Okay, so here we have destruction of infected self cells, displaying foreign antigen. So again, we have that foreign antigen, the antigen of the pathogen, okay? And that's what our T killer cells are responding to. They're saying, you can't hide there. We're going to destroy this entire self cell in order to get at you, the bacteria, or whatever other pathogen is deciding to hide inside that cell. Okay, so we have now the T cells. We have the B cells. We have everything working together. Okay? And what we're pulling out from this is that we have quite a massive response. So what is all this talk then about memory cells? Why do we need memory cells? So let's talk a moment about the secondary immune response. So it's nice to do this with a little bit of a graph. And let's look at antibody concentration. Against time. So we start out with none. We go up, we have a peak, we come down, and then we go really steeply up. Okay, so there's two really important, oops, I hate the fact that it undoes everything when you do it. You can't just erase a little bit. Okay, let's do it again. A little bit up, really steep up, and down. Okay, so there are two important features here. Okay, one of them is that this response here is steeper. It's a faster response. So, oh, we should have started it at the very beginning, hey? This was the primary immune response, where we created those memory cells. This here is our secondary immune response. Okay, so two special features of that secondary immune response that make it different to that primary immune response. First one is that it is a faster response. So maybe it took a week the first time round. Now it takes 2 days. The other major feature of the secondary immune response is that it is a larger response. We have, like in my dodgy graph here, we have double the number of antibodies produced, double the concentration of antibodies in the secondary as for the primary, and it's happened a whole lot faster. And that's what it is about the secondary immune response. The secondary immune response is faster and larger than the primary immune response, and that is because of the memory cells. The secondary immune response is exactly the same as the primary immune response. Pathogen enters. Antigen is responded to by complementary B cells. Antigens presented by the macrophage. T cells respond. Okay, B cells make memory cells and plasma cells. T cells make helpers and killers. And it all works through exactly the same. Thing is, remember, you got one cell dividing to make 2, then they divide and we get 4, then they divide and we get, what, 8, and then it goes on and on, right? But we've got to start from somewhere. Now, the thing about that secondary immune response is your memory cells also kick in. So it's not just your initial B cell expansion, it's also your memory cells expand. So if you think, instead of starting from 1, now you're starting from 10, or you're starting from 100. And the same thing with your T cells. Your T helpers turn into memory cells. So you're not just starting from 1 helper cells, you're starting from 10 helper cells or 100 helper cells. Now you get so much more cytokines released. So now your B cells are dividing even faster. So the whole process is like ramped up even more so because you have these memory cells involved. So the first time you get the cold, you might get sick. Second time you get the cold, you might sniffle for a day and then it's over. You don't get it again. And this is the whole sort of understanding behind the secondary immune response, is that the technical specifics of it are no different. But because you're starting from a point where you have memory cells as well, you get this faster and larger response. And in many cases, in our everyday life, quite thankfully, we can fight off these pathogens before they actually have a chance to get busy causing a problem in our life. This is also the basis behind the whole theory of vaccination, because with a vaccination, you cause that primary immune response, okay? But you used an attenuated organism, or you use just a preparation of antigens. So the person's not going to get sick, but they're going to have this primary response, and they're going to create those memory cells. Then, if they are exposed to the actual nasty pathogen that would make them very sick, then we've got a secondary immune response, and we're fighting off that pathogen before we get the chance to be properly sick. So it's all a game of numbers when it comes to immunity, and a game of time to respond. Can we respond and kill off the pathogen quicker than the pathogen can replicate and cause a problem? And our secondary immune response goes a long way towards doing that because of those memory cells. So it's really important that you take the time to get familiar with each piece of this immune response, so that you've got that understanding of where things happen and how things are linked together and who does what at the end of the day. And then you take that same knowledge into your secondary immune response plus your memory cells, so that everything ties together faster and larger. Two very important adjectives to use in describing your secondary immune response.